So this is the Year 11 mole and Avogadro's constant test. We're going to have a look at the multiple choice questions. Question 1 says, the mole is used as a measure of substance in chemistry. In terms of which one of the following is it defined? So going back to our definitions, 1 mole is equivalent to 6.02 times 10 to the 23 particles. So this is our definition of what a mole is. Now, you know, chemists don't really want to be working with very large numbers. We want to compress it down. So a mole represents this quantity of particles, but we're going to be working with mole usually because it's smaller, it's easier to use, and it's, you know, universally understood, so and agreed upon. Therefore, in this question, in terms of which one of the following is it defined, it is the number of particles. So we know that the mole represents how many particles we have, which is the same as Avogadro's constant. Okay, so question 2, which is a correct definition of the term empirical formula? So remembering, before we even answer the question, remembering that empirical formula, say we have the molecular formula of glucose. So that's the molecular, which is the actual formula of glucose. The empirical formula would be the lowest ratios of atoms. So it would be more so like C1, I'm not going to write the 1 there, H2O. So that would be the empirical. Okay, so we can see, in essence, the empirical formula doesn't really mean anything. Okay, so it's not the real formula of the molecule. It is the smallest amount of ratios between each atoms. So out of all of these, the option D makes most sense. Formula showing the simplest ratio of numbers of atoms of each element in a compound. So it's D. Okay, let's have a look at question 3. Which contains the same number of ions as the value of Avogadro's constant? So Avogadro's constant, Na, is 6.02 times 10 to the 23, which is the same as 1 mole. So within these options here, we want to find the number of ions that gives us basically 1 mole, because 1 mole would be 6.02 times 10 to the 23, which is Avogadro's constant. Okay, so if we look at option A is, if we look at sodium chloride actually has 2 ions in it, sodium and chloride, and we take 0.5 mole and we're going to times it by 2 because there are 2 ions, which gives us 1 mole of ions. 1 mole of ions means Avogadro's constant, because we know that 1 mole, as I wrote down here, 1 mole is the same as Avogadro's constant. So it's actually, the answer will be A, but we'll have a look at why it's not B. So B, we have 0.5 mole, but in this situation we have 3 ions because there are 2 chloride. So we times it by 3, which is 1.5 mole, which is not what we're looking for. In question C, we can see that there are also 3 ions, and this time we have 1 mole times by 3, which is equal to 3 mole. So it's definitely not going to be C, it's not going to be B. And then D is 1 mole times by, in that combination we have only 2 ions, so 2 mole. Again, not the answer we're looking for. We're looking for 1 mole. Okay, the final value as 1 mole. So A is the answer in question 3. Let's have a look at question 4. The population of Australia is about this amount. The Australian population could be represented as, you can see all the values here, they're in mole. So this value here is number. Okay, so the number of Australian people. So we can actually get the mole of Australian people. The mole is equal to the number divided by Avogadro's constant. And so the number of people in Australia is this. Avogadro's constant is this. Making sure that you keep your brackets and around these values in particular, because you might get something strange if you don't. When you work this out, you get 3.488 times 10 to the negative 17 mole. Okay, so it means that the answer here will be A. Okay, so that's how many mole of people the Australian population has. So that's just getting you to understand what mole really represents. That it actually represents a huge quantity, but you don't see it because it's compressed. Okay, so let's have a look at the next page. So question 5, which expression gives the amount of mole in of a substance if the mass is given in grams? So remembering that the mass is equal to mole times molar mass, and if you want to get mole, you have to divide the mass by the molar mass. And in terms of this question, the answer is A. Mass divided by molar mass will give you the mole. Question 6. How many molecules are present in a drop of water of mass of this? So this is the mass of water. So let's have a look. So the mass of water is equal to 9 times 10 to the negative 2 grams. The molar mass of water is 18 gram per mole. And so what we need to do is, first of all, we need to figure out how much mole of water we're working with. So to do that, we take the mass. You can see in question 5, we take the mass and we divide it by the molar mass, and that gives us 0.005 mole. And then with that, we actually need to work out how many molecules. So we need to work out the number of them. So if we go back to our calculation, so number of water molecules is, we take this mole amount here and we times it by Avogadro's constant. So 0.005 times by Avogadro's constant, so 6.022 times 10 to the 23, and we should get number of water particles should be equal to 3.01 times 10 to the 21, which is option number, or option B. No, sorry, A. Sorry, it's a bit hard for me to see the cursor here because it's really tiny. So A. Alright, so question 7. In question 7 we are finding the mass, the relative atomic mass of element X. And we're given, what we're given here is, we're told that there's 75% of this in abundance and there's 25% of this, and we're also given the relative isotopic masses. So we're asked to find the relative atomic mass of element X, which remember what you need to do is you need to take the relative isotopic masses, so 35, times it by its percentage, so 75, and add it to the other isotope and its percentage. So 37 times by 25, divide it all by 100, and when you work that out you get 35.5, which is answer B. 35.5. Alright, let's have a look at the next page. Okay. So in this next page we have what amount of oxygen in mole contains 1.8 times 10 to the 22 molecules. Okay, so this is kind of the reverse of what we have been doing so far. So we have the number of the molecules of oxygen. So we have number of oxygen molecules and we're told it's 1.8 times 10 to the 22. Okay, so what we can do is we can use, because we want to find mole, we can use the number divided by Avogadro's constant. So we're told what our mole number of oxygen particles is, and then we divide it by 6.02 times 10 to the 23. Now, making sure you have brackets around your answers when you put this into your calculator, otherwise it will give you a really weird number. But when you do that, you get 0.0299, which to the correct significant figures will be 0.03. Okay, so answer B. In this situation. Okay, so question 9. How many moles of sodium hydroxide is present in 2 grams? So in question 9, we know the mass of sodium hydroxide. We know it's 2 grams. We know we can calculate the molar mass of sodium hydroxide, and that's just from the periodic table. So we know the molar mass of sodium, oxygen and hydrogen, 23 plus 16 plus 1, which is 40 gram per mole. And then we can just work out the mole of sodium hydroxide, which is the mass divided by the molar mass. So 2 divided by 40, which happens to be 0.05. So 0.05 mole. So it is option A. Okay, question 10. TNB is an organic compound similar to TNT. Fantastic. The empirical formula of TNB is that. So I'm just going to write this down. Empirical C2H&O2. And the molecular, sorry about my handwriting there, the molecular is unknown. What we know is that the molecular molar mass is 213 gram per mole. We need to actually find empirical molar mass. Now, when we work that out, the empirical molar mass in this question happens to be 71 gram per mole. And what we can do is we can work out a ratio. So what the ratio is you compare the molecular molar mass to the empirical molar mass, and what you get when you divide 213 over 71 is you get 3. And so to get your molecular molar mass, you have to times everything by 3. All the atoms need to be times by 3, so you're going to get C6H3N3O6. And so your answer is going to be C. Okay. So, question 11. A compound is found to have an empirical formula of this. Okay, so we'll do the same thing. We'll write empirical formula. Handwriting today is shocking. Okay, so we have CH2O, and we don't know a molecular formula. So that's the point of this question, and we are told that, well, we still need to find the empirical molar mass. So 12 plus 2 plus 16 gives us 30 for our empirical molar mass. For our molecular molar mass, we're not really given that, but we are given the mole and we are given the mass. And so from that information, we can actually calculate the molecular molar mass by, remember that molar mass can be found by taking the mass and dividing it by the mole. So in this situation, we are told that 90 grams gives us a mole of 0.5. And when you work that out, that gives us a quantity of 180 gram per mole. And therefore we can calculate the ratio. So the ratio is 180 divided by 30, which happens to be 6. So the empirical formula needs to be multiplied by 6 in order to get the molecular formula. So C6H12O6 is the substance. So in this case it is D. The answer is D. Sorry, struggling finding the cursor because it is so tiny. Okay, so D. Okay, question 12. The percentage by mass of hydrogen in pure C2H5OH, which is ethanol. So if you wanted to find the percentage of hydrogen, you need to work out the total molar mass of this whole thing. So the molar mass of the whole thing is actually, if you calculate it, it's 46. Okay, so that's 46 gram per mole. So 46 goes down there at the bottom, the total. And then you also need to figure out how many hydrogens are in this compound. So you can see that 6 hydrogens, and it's 6 times by the molar mass of hydrogen, which is 1. So that's why I said 6. And the whole thing then needs to be multiplied by 100. So what you end up with is 13%. So your answer is B in question 12. Okay, question 13. How many hydrogen atoms are contained in 1 mole of ethanol? How many? So that's number of hydrogen atoms that are contained in 1 mole of ethanol. Okay, so ethanol, there's 1 mole of it. Now, what we want to do is we want to find how many hydrogens there are. Now, in every molecule of ethanol, there are actually, if you count them, there's 6 mole of hydrogen. And you're essentially taking that value and you're timesing it by 6 to get the hydrogens. Now, you can't, your answer is not 6 because it's asking you how many. So that's capital NH. So you're timesing 6 by Avogadro's constant. So 6 by this, which gives us 3.612 times 10 to the 24 atoms. And atoms of hydrogen in particular. So it's option D. Okay, question 14. Which sample has least amount of atoms? Now, with the least amount of atoms, it's best to compare each one side by side with how many atoms they have, and conveniently they're all in mole, which is really useful. So you can see this one has 1 mole times by, if you wanted to convert it into atoms, you need to count how many atoms you have. In this case it's 7, so 7 mole of atoms. In this case 1 mole of this substance here, if you count how many atoms, that's 1 plus 3 plus 1 plus 1 plus 1 plus 1, so that's times by 8. In this case, we actually have double the amount of moles, so we have to go 2 times by the atoms, which is 4. So it's still 8 mole of atoms. And in this case, it's 2 times by, again, that's 4 atoms. Now, here you can proceed to finding the amount of them, but you know that it's dependent on the mole. So if you times all of these by Avogadro's constant, you know, you're still going to get, it's going to all be dependent on how much mole you have. So the least amount of atoms is actually A, because it has the least amount of mole. Okay, so question 15. What is the total number of atoms, so capital N, of propanon? Okay, so, and you know the quantity as well, which is useful. Alright, so with question 15, we're going to find the number of atoms. We are going to be using the 0.2, going to be timesing it by Avogadro's constant, and we have to convert it into atoms, not propanon. Okay, so in every propanon molecule there are 10 atoms. Okay, so when you work that out, you get 1.204 times 10 to the 24 atoms. Okay, so that means the answer is C. Okay, question 16. How many atoms of oxygen are present in this amount of carbon dioxide? So we know the mole of carbon dioxide happens to be 0.05 mole, and so then we know we can find the number of carbon dioxide molecules by taking this value and timesing by Avogadro's constant, which happens to be whatever value it is, and then we can proceed to the number of oxygen atoms. So the number of oxygen atoms is, in every carbon dioxide there are 2 oxygen atoms. So we would have to go 2 times by 0.05 times by 0 is Avogadro's constant. Okay, and when you work this out, it is answer B. Oh, sorry. Let me just double check. Yes, it is answer B. Okay. So, and you can see that because, I mean, this part here becomes 0.1 times 6.02 times 10 to the 23, and that reduces this power by 1, which is why the answer is to the power of 22. Okay, question 17. What's the molar mass of NH4,2SO4? Let's try to scroll down a bit. Alright, so well, this 2 out here acts like a expanding a bracket, meaning there are 2 nitrogens, 8 hydrogens, only 1 sulfur, and 4 oxygens. And to figure out the molar mass, we have to add them all up together. So 2 times by 14 plus 8 times by 1 plus 1 times by 32 plus 4 times by 16. And you'll notice that my molar masses aren't very accurate here. This will give us 132 gram per mole. But, you know, from your answers here, you can select option C, because it's the closest one to our approximation there. Okay, let's have a look at page 5. Alright, so page 5, we have question 18. Which of the following has or have the empirical formula of CH2O? Now, to figure this out from our options, this one here needs to be, you need to figure out how many carbons, how many hydrogens, and how many oxygens it has, which is not very clear until you condense it. So there are 2 carbons, the hydrogen number is 4, and the oxygen number is 2. And what we can do is, if we're converting that into an empirical formula, we have to divide by 2. We have to divide everything by 2 in this case, so it becomes CH2O. Okay, now if we do the same for this one and divide by 6, we're going to get C2, no we're not, we're going to get CH2. O. Now if we try to get that one into an empirical formula, well, there's no common ratio there. So that just gives you nothing. I think that is actually the empirical formula. So it's not going to be that one. Remember, the question is asking specifically this compound here. So we are looking for option C, which is 1 and 2 only. Okay. Let me just get up to my notes here as well. Okay, great. Alright, so question 19. Which has the greatest mass? So these are the annoying questions where you have to convert into mass. So 4 mole of oxygen atoms. Now if we do A, 4 mole of oxygen atoms, to figure out the mass of oxygen, we have to take the mole that we have, and we have to multiply it by the molar mass. That's our formula for figuring out our mass. So in this situation, we'll take 4, we times it by the molar mass of oxygen, which is 16, and we get 64 grams. Okay, if we look at option B tells us how many atoms of helium we have. Okay, so we need to first work out the mole of helium, which is the number divided by Avogadro's constant. And you can see the 6's will cancel and you'll get actually 100 mole of helium. And then we need to figure out the mass of helium. And we do that by taking the mole and timesing it by the molar mass. And that's done by going 100 times by the molar mass of helium, which is 400 grams. So helium's already heavier than the oxygen that we have encountered. Question C, 200 grams of iron. Luckily we don't need to really convert the iron because it's already given its mass. And remember, we're looking for the greatest mass. So far it's not A, it could be B, it's not C. Let's have a look at D. So D is 6 times 10 to the 25 molecules of hydrogen gas. So we're going to divide it by, again, we're going to find the mole of hydrogen gas, and once we find the mole of hydrogen gas, we need to figure out the mass of hydrogen gas. So we take 100 mole and we times it by the molar mass, which is actually 200 grams. So it's not D, the answer is B. So it does take quite a lot of effort in these questions to get the right answer. Not easy process, but yeah, you have to go through all the steps. So question 20, which one of the following contains the greatest number of molecules? So N. Okay, so we're going to have to find the mole of each one of these. So the mole for this one, for CH3Cl, it's 1 gram divided by the molar mass. So when you calculate the molar mass, it's 50.5, which gives us an answer of 0.0198 mole. When you work out the mole of that one, it's 1/84.9. You work out the mole, it happens to be 0.0117. You work out this one, you get the mole of the compound as being 1/119.35, which is You know, as the molar mass of the substance increases, the mole will actually reduce. So 0.00837 mole. And finally, for this one here, you have the mole of the substance, 1 divided by 153.8, which happens to be 0.006 mole. So as the you're essentially here, you're looking for the molar mass that's the least, because remember, you're assuming in this case that everything is 1 gram, which it is, and you're dividing it by the molar mass. So the mole of this substance A actually ends up being the greatest mole, and in every case you're going to be timesing it by Avogadro's constant. Okay, so since you're going to be timesing it by Avogadro's constant, the largest the mole, the greater is the number of molecules, so it's actually going to be A in this situation. Okay, so question 21. Oops, sorry. I'm just always trying to identify my clicker in these questions. So that's A. Which of the following quantities has units? Anything relative never has units, because it's always a comparison between something. Mass number is the protons plus the neutrons, so no units. The only one left is C. So that was not too bad. Okay. Finally, last page of the multiple choice questions. What is the total number of ions present in this formula? So Al2SO4 3. Well, you can you know you have 2 aluminium and 3 sulfate ions. So 2 plus 3 equals to 5. 5 ions. Okay, so your answer here would be C, 5. Okay, question 23. Okay, so you have a empirical formula of a compound containing 50% of mass of element X and 50% of mass element Y. AR stands for atomic relative mass, which is the same as just the molar mass of the compound. So you have X compared to Y. The molar mass of compound X, I'll write it here, is equal to 20. The molar mass of compound Y is equal to 25. Now, from the 50%, what the 50% tells you is you have the same amount. So you can just make up your own amount. Let's say the mole of X is equal to 1 and the mole of Y is equal to 1, because the same amount, 50 to 50. If it happens to be different, then these ratios would be different. If it was 40%, this would be maybe 0.4, that would be 0.6. That's how I would change it. But in this case, it's 1 to 1. Okay, so what we can do from there is we can find the whoops, I'm sorry, I'm going to change these to masses, not moles, because it does tell us that it's mass of X and mass of Y is the same. So I'm going to find the mole of X, which is 1 over 20, 0.05, and the mole of Y, which is 1 over 25, which is equal to 0.04. And I'm going to write them down here, 0.05 and 0.04. And then we just divide it by the lowest ratio, which is 0.04. So we get 1.2521. And then we times all of that by 4. And we get 5 to 4. So the answer in this case will be D. X5, Y4. Okay. Option 24. Which one of the following sequences is the correct sequence for the process in a mass spectrometer? So in a mass spectrometer, remember that first you've got the vaporization stage, then you have the vapor is bombarded by high-speed electrons, which means it's turned into an ion. The substance is turned into an ion. Then it accelerates, and then there's the separation that occurs. So deflection should be the very last thing, so it's definitely not going to be D. Vaporization, ionization, acceleration, deflection. It looks like it's A. That's just a definition of what the mass spectrometer does. Question 25, final question of multiple choice. You're asked to find the relative atomic mass of Z. So relative atomic mass of Z is equal to the relative isotopic masses, which you get from those numbers there. So 69 times by the percentage of abundance times by 60 plus 71 times by 40, and divide it all by 100 and then figure it out. It gives you 69.8 as the relative atomic mass of Z. So the answer should be B. Okay, so that concludes our multiple choice component. So thank you for listening, and please join me for the short answer questions that are coming up.